Welcome to another episode of the Burbank High School Chemistry Labs. Today we have the Atomic Coating Lab.
Ready? Action!
There. Hello, boys and girls. Today, lab number 2, we're going to don't laugh, guys. We're going to do a lab. It's a very interesting lab. We're going to use some acid and we're going to use some galvanized iron. If you don't know what galvanized iron is, it's iron. That has zinc coated on both sides. So it's an alloy, and here's Mr. Iwan to show you the concept behind it.
All right, so we are going to do the atomic coatings lab. We have zinc, okay? You can find this on your periodic table. It's ZN. What number is it on the periodic table?
Number 30.
Number 30,
Yeah.
okay? Notice we have an S here. What do you think the S stands for? The S stands for solid. So it's solid zinc, okay? We're going to pour in some HCl. HCl is a very strong acid. It stands for hydrogen chloride, so hydrochloric acid. The AQ here stands for aqueous, which is liquid. Essentially, it's a liquid. Okay, that's all you need to know right now. It's going to go to zinc chloride, okay, which is also aqueous, and then it's going to produce H2, which is hydrogen gas. G is for the gas. Notice how, we haven't gotten to this yet, but notice how you have one zinc here, you have one zinc here, you have two chlorides here, two chlorides, two H's, and two H's. So the equation is balanced, which we'll get to in a later section.
Yes, sir.
Okay? Now what we're going to do is we're going to take a small piece. This is iron coated with zinc, okay? And we
There
have
you go.
here a diagram. So if you looked at it on the side, you'd have zinc on top, zinc on the bottom. And what we're going to do is we are going to come along and pour the HCl in, and we're going to just basically eat off, like Pac-Man, waka waka waka. We're going to eat off the zinc, we're going to be left with the iron. Okay? So we're going to see what happens. So are you ready?
So, we're gonna get started, and one more thing I just thought I'd add in. The reason why they coat the iron with zinc is because zinc isn't as reactive with the oxygen and it doesn't rust. And you will see, but iron is very reactive with the oxygen. So you'll see, the iron will not look so good after the zinc has been removed. So here we go.
Iron and his brother Ryan.
Ryan, yes, okay. Weigh a piece of galvanized iron on the electronic balance.
All right, we got our balance. Make sure it's always zeroed or tared out. And should read 0. Put it on our piece of metal, and I read 3.16 grams.
3.16. Okay, so boys and girls, we're back. Okay. Your teacher might go over this with you, right? This is the data table. We're collecting data for just one group right now. This is for 2 groups. So notice right here, is it showing up there? Okay.
Yeah.
I move that up. Okay, I wrote 3.16 for the mass of galvanized iron, right, before the reaction. Lift it up. And notice what I did, what is going on here, right? And this is something if you go on to higher level chemistry classes, you want to make sure you know this when you have a lab notebook, right? You got to write the unit after each number, right? Because you can't just say a number, because we don't know what you're talking about. Cats, dogs, Flugenflorgens, or grams, right? This is grams. Now, if you don't want to write the unit after each number, you can put the unit in parentheses in next to the description, and that tells the reader that every number here is in grams. Okay? So it's 3.16 grams, and let's get to the next step.
All right, so I think it says to measure it, length and width.
Yes, step number 2 is to measure the length and width
All right, so
of the galvanized iron.
We'll use
in centimeters.
a ruler for that. Always make sure that we use the.
I like that one.
Make sure that you use the centimeter scale, not the inches scale. So using centimeters, line up your 0, and I read 3 point, it's kind of in between 1 and 2, so I'm going to go 3.15.
There you go. Okay.
And the next one would be 3.1. Light up, brother. Here, I'll do it this way.
You can play like, you can make like a weird comment.
3.1. And it's kind of in between the 3.1 and the 3.2, so I called it 3.15.
Excellent. That's a good precursor to Siegfried.
There.
Okay, so I wrote down Mr. Dixon's measurements, right? 3.15 for the length and 3.1 centimeters for the width. Okay, now it really doesn't matter which one you call the length and the width, because in the calculations down the line, you're going to multiply them together anyway. So it's the product that matters, it's the area. All right, so, but you can see, right, the centimeters unit is written right here in parentheses next to the title of the measurement, so you don't have to write it after each number. All right? And now we have all our dimensions and our measurements that we need before the reaction, so here we go. And
all right, so the next step says measure out approximately 20 milliliters of 3 molar hydrochloric acid using your graduated cylinder and take it back to your lab table. So we have some 3 molar hydrochloric here. I have a graduated cylinder. And it says approximately, so you know, if I'm at 17, it's fine. If I'm at 22. Now, one thing that I stress with my students is when you're pouring into a graduated cylinder, don't do this, right? You're exposing yourself to a lot of, so we need to measure out 20 milliliters of hydrochloric acid. And one of the things I stress with my students is when you're pouring into a graduated cylinder, have it flat on the table. Use one hand to hold it nice and secure, and then you go down to it so that you're pouring onto a nice stable thing. So we just need about 20 milliliters. That looks about 15. That looks like about 18. There, I went over 20. That's a little too much. I got like 27, but that's fine. Okay. Take it back to my lab station.
And he's back.
And I'm back. Place your galvanized iron in a 250 milliliter beaker, like so.
Get ready.
Allow the reaction to complete, and then pour the HCl on it. So here's the fun part. And look, it's doing nothing. No, I'm kidding. And you can see the bubbling.
So that bubbling is the hydrogen gas
Yep.
being produced and escaping into the atmosphere.
So we're converting the zinc into zinc chloride, and as a result, the hydrogen is being released from the hydrochloric acid. The chlorine, this is a single substitution?
Yeah, single replacement.
Single replacement reaction. So the chlorine, it's swapping cations. Yeah, the chlorine is originally with hydrogen and it's going to zinc. But yeah, oh, it's starting to go good. One of the things you can do is just a gentle swirl. That just makes sure that the products of the reaction get out of the way so that more of the zinc is exposed to the acid. It's going pretty good. This will probably take a couple minutes, so we might want to do a montage.
Bob, talk about your brontosaurus that you were laying on.
That was funny.
Yeah, that was a good little comment.
Looks like it's slowing down a little bit.
Yeah, I usually just tell them, be patient, swirl it, make sure you get both sides, and then
Bubbles are really fine now.
yeah, when there's no more bubbling, and pretty much you're done. I mean,
It's almost there.
Don't look
We
directly
need to get a
into
paper
them.
towel out to put it on.
I'll get one.
Swatch. A swatch. A paper towel.
No bubbling that I can see going on anymore. I just did something wrong. I looked into it.
But you have your goggles.
I have my goggles on, and I'd already verified that the bubbling had stopped. So now we're gonna complete the reaction by just.
And this is also a safety measure to
Right.
dilute any excess acid.
Now it's dilute. I'm just gonna do this a couple times, and then I could actually just use my fingers at that point because it'll be water. All right, now I can catch the metal, put it onto some paper towels. We gotta dry it because we're gonna do what again?
We're gonna weigh it again.
Weigh it again.
We wanna make sure there's no water on there.
Okay, so that looks pretty good. This thing is zeroed. Well, it was zeroed, there it goes. And the new weight is 3.04.
Nice, okay. And as you can see, this 3.16 grams was with the zinc on both sides, but since the acid dissolved it away, now the mass of iron after the zinc has been removed, it's no longer galvanized, it's 3.04. And in separate classes, we will do the calculations. And you'll see why we're doing this lab at this point when we do the calculations. It's just kind of a good thing to do. Yeah. One last thing. You guys wait a few minutes, or maybe we'll show you in a few minutes that this degalvanized iron, it will get rusty already. Maybe in a couple minutes, but we got music to play in the interval. All right. Okay.
All right.
That's it. Don't mess with his hands. I'm very sensitive. All right. What are we doing?
Okay. All right, here we go.
Hand model.
So here's what it looks
Oh,
like.
well.
This is the rust, right?
Okay, so you can see what, boys and girls, when the iron has been degalvanized, the zinc coating has been removed, how rusty the iron can get. So,
Perfect.
again, you can buy galvanized iron at Home Depot and stuff, and hardware stores.
Chain link fencing.
Chain link fencing is galvanized iron. There you go.
Yeah.
So yeah, iron by itself, they usually coat it with things. There's aluminum coated iron, right? Yeah. For like iron gates, aluminum doesn't get as hot as iron. So anyway, but the acid dissolved the zinc, and that's pretty much the lab. And we'll go through the calculations at a later date. And that's it. Thank you, everybody.
Right on. Good job.
All right. So.